Hey guys, welcome to Safi Mixed. In this video, I use binomial distribution to solve two different examples and would discuss the drastic change in the output of the binomial distribution with the increase of the number of particles, because the number of particles in fact changes the number of possible ways of the distribution of particles. So to begin with, I consider a box, in fact, a kind of rectangular box, and make a hypothetical partition in the box such that the left side of the box is 1/3 of its width and the right side is obviously then 2/3 of the width, and we fill the box with different number of particles. In this particular case, I have put 6 particles in the box, and these particles are in fact in random motion. So we want to see, although I am unable to show the motion to be very uniform, but this is a random motion, and we want to see what is the probability for 1/3 of the particles. Obviously, 1/3 of the 6 particles is 2 particles. So we want to see that 1/3 of the particles at any instant be in 1/3 of the left partition of the box. So in order to find the probability for 2 particles or 1/3 of the total particles to be in the left 1/3 of the box, I use binomial distribution. And we know that the probability through binomial distribution is given by n factorial divided by small n factorial times capital N minus small n factorial p raised to the power small n and 1 minus p raised to the power n minus capital N minus small n. So in order to understand the meanings of these parameters appearing in the binomial distribution, I just want to comment on them. P of n, the small n, is in fact the frequency of successes. Capital N is the total number of trials. So in this case, the total number of trials is in fact equal to the total number of particles, and small n is the number of particles to be in the left 1/3 of the box. Then p, the success probability for this box, is 1/3, and 1 minus p is the failure, which is 2/3. So with these values, I can specifically write that the number of particles capital N equals 6, the number of particles to be in the left is 2, and the probability of success is 1/3. This 1/3 in fact corresponds to 1/3 portion of the box. Then putting these values, we can find that the probability for 2 particles to be in the left 1/3 of the box is in fact given by 6 factorial divided by 2 factorial into 6 minus 2 factorials 1/3 raised to the power 2, and then 1 minus p are 2/3 raised to the power 6 minus 2 equals 4. And if we find the numerical value, it goes like 0.33. That is, the probability for 1/3 of the particles to be in the left 1/3 of the box is almost 1/3. Okay, the things are going very fair, but what if we increase the number of particles in the box? Will the same probability be intact? That is, let's the number of particles in the box be 60, and we want to find 1/3 of the total particles. So 1/3 of the 60 particles is 20 particles. So that means we want to see 20 particles into the 1/3 of the left portion of the box. For that case, the probability for 20 particles to be in 1/3 of the box is then out of 60 particles. So I'm taking 60 factorial, would go like this: 20 factorial, 60 minus 20 factorial, and 1/3 raised to the power 20 and 2/3 raised to the power 40, because 60 minus 20 is 40. And if we make this calculation, it goes like 0.11. Obviously, 0.11 is almost 1/3 of this probability. So that means when the number of particles is increasing in this distribution, it is not always necessary that one third of the particles be in the left one third of the box. That means the number of ways for the particle to redistribute themselves increases with the increasing number of particles, and that's why the probability for different distribution changes as per this thing, because this is the number of ways that the particle redistribute as the number of total particle increases. So this is not necessary that always one third of the particles be accommodating in one third of the box. Rather the probability for one third of the particles to be in one third on the left to be in one third of the left of the box changes as the number of particles increases. So this is the beauty of binomial distribution, which goes parallel with the everyday observations. At the end, if you haven't subscribed to Safi Mix, kindly support the channel by pressing the subscribe button and also hit the like button in the video. Thanks for watching.